forgot to do it. Second. A big part of today's new proofs is being able to identify two statements that are called contradictions. So let me talk about the word contradiction first. What's it mean to contradict? Well, math terms, it means two statements that can never happen at the same time. Right? Two mathematical statements that cannot happen at the same time. So what I did for you first, before we even step into a proof, is the following. I gave you three math statements. DEF is scalene, DEF is a right triangle, and angle D is congruent to angle F. Two of those, I hate to break it to you, can never happen at the same time. Two of those can never happen at the same time. You and your group are going to talk about it now. Which two of those, no chance can happen at the same time mathematically, if you know your vocabulary. Talk it over. Go ahead. I'll give you some time. Woo! You got to remember what the vocab means. I have questions for you.
So it can't be speed, right? If it's
I got to do it on the last quiz. So I have to do it. Somebody got to remind us on Monday's test to write some combinations.
I don't know. So angle scaling is contradict. Like where, like let's say. Oh yeah, doctors or something. And then goes like, how do you like your toast? However do you like your toast? So I would probably do no. 10 being charred.
All right, let's get back. Ready? Here we go. What did you and your group decide? Which two statements contradicted each other? Oh, 21 contradicted each other. Do I have a 21?
Yeah.
Did we talk in our group?
Yes. I think we said 1 and 2.
Everyone agree that's a right triangle? Is it scalene? Is it right? So can they both happen at the same time? Okay, so they can happen at the same time. Right here is a right scalene triangle. So 1 and 2 do not contradict each other. 18 got another pair that might contradict each other. 1 and 3. Scalene we just went over. All three sides are different. But if two angles in the same triangle are congruent, that makes it. Can't be scalene and isosceles at the same time, right? So those two contradict each other. All right, everyone see now the meaning contradict each other. Cannot happen at the same time. Cannot happen at the same time. All right. All right, we're going to start a new proof here today. It's called an indirect proof. This right here, I am not reading these to you or trying to explain it. We're going to hop right into the fire and do an actual indirect proof. This here is just for tonight. If you forget the steps and you need a little reminder, it's here for you. All right, I just want to hop right in to an indirect proof. Well, let's just take a look at this. Let's not write anything down. What's so different about this? You guys have gone through, oh boy, 3 months of proofs now with me. 4 units worth of proofs. Probably we're approaching 100 proofs done. What's so different about this one versus all of them we've done in the past? Tammy, what's so different? You see right away. When have I ever asked you to prove something not happening? Never. Never. And right there in the proof statement, when I ask you to prove something's not happening, ding, 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 signals, it's time to do this proof a little differently. I got to do what's called an indirect proof. Okay? Anytime I'm asking you to prove something is not happening, this type of proof cannot be applied to what we've already done this year. Okay? It can only, proving triangle ABC congruent to DEF, I'm just doing that the normal way. I'm only going to use an indirect proof if I'm asked to prove something's not happening. Well, you guys see step number 1? That's no different, right? Write out your givens. I've always showed you that. You guys always do that. Step 1, no big deal. All right, let's mark our diagram. AB is congruent to BC. Ooh, and that's something new too, huh? Have we ever seen that in a given? Something's not equal to each other in the given? No, we have never seen that. All right. I can't really mark, I'm not going to mark that on my diagram, but all right. This first proof here, I'm just going to basically do for you and tie it all together at the end. It's going to be uncomfortable. That's why we got 2 more to go as a class, though. All right, it's going to feel a little uncomfortable. Ask as many questions as you want. All right. Here's where an indirect proof starts to get different, is in step 2. We're going to assume something is true. We're going to make an assumption. And here's our assumption. We're going to assume the opposite of the proof statement is true. The opposite of the proof statement. So what would be the opposite of A not congruent to C? A is congruent to C. So we are going to assume the opposite of that proof statement is true. And we're just going to call that in our reasons column our assumption. And we're going to mark the diagram. And we're going to say A, with our arc marks, is congruent to C. Watch where this leads us. This leads us into somewhere where we shouldn't be. Watch where this assumption leads us to. Everyone see these 2 overlapping triangles? See these 2 overlappers? You already have a pair of sides, right? Congruent, and a pair of angles. Can you and your group find one more pair so I can prove the whole thing's congruent? Can you do that for me? I already have angles and sides. I need one more pair of something. Can you guys in your group? This is nothing new. This is old school. All right, this is nothing new right now. Find me another pair of angles or sides you know are congruent. Let's roll. Let's roll. Talk it over with your group. You can't use the givens anymore. They're done. We've used all the givens. So this is something you got to find on your own looking at the diagram. Give me another pair of sides or angles that are congruent and those 2 overlappers.
We can prove them triangles and then assume that we're wrong and say assumption wrong.
Okay, what did you and your group find? 3? Eva, what did you and your group find else is true? Good job. Angle B is shared by both. Everyone good? Angle B, congruent to itself. Reflexive. And I want you to keep in the back of your mind what is allowing us to write all this is that darn assumption we assumed at the beginning was true. So everything we're about to write was because of the assumption. What do we now know about the triangles? Okay, let's do it. Triangle ABE, congruent to triangle CBD. Ooh, yeah. Here's a little going back in time. Method. Oh, Eva, again. Good job. That side's in between. Way to put it in between. Angle, side, angle. All right. Ready? We got the triangles congruent. That usually means now, aren't all the sides and angles equal? Yes, all the sides and angles are equal. Can somebody give me a pair of sides that are now congruent because the triangles are now congruent? Give me a pair of sides that are now congruent. Give me a pair of sides. 22. Can you find a pair of sides that are congruent? DC and AE? True. Yes. Everyone agrees? DC and AE? I'm not going to write it down. You'll see why in a second. But yes, AE and DC are congruent. Name another pair that are congruent. There's only one more pair left. What other pair are equal up here now? 14. What's the other pair? Oh, we don't have one, guy. I was not smoking, going crazy. Eva, again, look at that. What's my other pair that are equal? I got the given pair. Quan just said AE and DC. What's the third pair now? We haven't said.
Wait, what?
You want to say that again for me?
Wait, sorry, what's the question?
No. What was the third pair that's congruent now? You're right. I'm not questioning you. You're right. I'm concerned now, though. I'm very concerned. Why? What do we got in our proof here? Mahmoud, what's the deal? Why am I going crazy up here? Yeah, whoa. You told me they weren't. And all of a sudden, now they are. That can't happen in a proof, right, kids? Can't happen. You can't have one pair being congruent and not congruent, and then all of a sudden they are. That doesn't happen. So you ready? What led us here for these two to be congruent? Angle A congruent to angle C. Is that a true statement? No, because it led us to this false statement. Everyone, yes? So watch. Don't write it down. Are we okay why this is false? Because it led us to this, which we know is not true. So I want you to think about this right now. If A congruent to C is false, what's true? If A congruent to C is a false statement, what's true now? The opposite, which is A is not congruent to C. We just said your assumption's garbage, hot garbage, because it led us to BD being equal to BE. So if that's false, the opposite, it's got to be true. And here's our final reason. And it's going to make sense, right? Our assumption, what we started with, ready? Our assumption led to A. Oh, I don't want to use that language. That's why I started the class off the way I did today. What are these called? Yeah, I know, opposites, but what word did we use, Mahmoud? Contradiction. Assumption led to a contradiction. I'm not done yet. Let me go through this one more time. Are we all in agreement statement 5 is false? Because in the givens, this is what was true. So if that's false, what do we know about our assumption then? That led us there. Our assumption is false. So what's got to be true then? The opposite of it, which is A not congruent to C. Yes, no, maybe? Last thing I need, though, is for you to prove that you know where the contradiction is. So after you write assumption led to contradiction, I need a pair of brackets telling me the 2 steps where the contradiction occurs. What contradiction are you talking about? Where is it located in your proof? Well, it's from the given, step 1, right? BD not equal to BE. And where did I contradict that? In statement 5. So I need the 2 lines where you contradicted yourself. The givens always, and then where else did you contradict that given? Whew. Go ahead, Serena, I'm ready.
Will it ever be more than just 2?
No. It's I can tell you, as long as you put your givens in step 1, it's always going to be step 1 and then wherever you contradicted that. Always. Hi, Caitlin.
You can never prove something congruent and then use it to contradict anything, right? Or
Say-
would it always be in the given?
Okay, now this is coming to my second point now. What are you going to contradict? You will always contradict one of the givens. And which one are you going to probably contradict? The one that's got the not with it. Okay, everyone's good here. You will always, what are you going to contradict in the proof? I don't know how many givens there will be, but you will contradict the given that's not equal to or has the word not with it. That's the easiest to contradict. Mahmoud, go ahead, let's go. Always the opposite of the proof statement, always. All right, one doesn't make you great. Let's keep rocking. One doesn't make you great. I want to start right from scratch. How do I know to do this proof indirectly? Because I'm just putting you guys in this spot. Let's say we're taking the midterm in a couple months. You have a proof in front of you. I am not going to say do it indirectly. But how are you going to know to do it indirectly? What up here is saying, hi, I need to be done not the normal way. I need to do it indirectly. Avery?
Does not.
In the proof, I'm proving something does not happen. Good. All right, let's take a deep breath. Givens are already written in. Step 2 is, what are we assuming is true then? Assumption. What are we going to assume is true here? Jonah?
BD bisects AC.
Good job. It is the opposite of the proof statement, always. BD bisects AC. How many givens did I provide you? How many givens? 2. You got to contradict one of them. One is much, much, much easier to contradict than the other. So you have ABC is not isosceles, and you have BD is an altitude. Which one is it going to be a heck of a lot easier to contradict? ABC is not isosceles. Why is that easier? How do you contradict that statement? Show me ABC is isosceles. You guys know how to do that. That's something we've done, proofs before. Are we okay on why I picked that one to contradict? Because how to contradict it, just show me it's isosceles now. That's on you guys now. You guys got to help me show this bad boy's isosceles. So show me ABC has 2 equal sides or 2 equal angles. That's your job with me right now. And you have the givens and your assumption to use. How am I going to show ABC has 2 equal sides or 2 equal angles is the question. With all this assumption and givens that you have. Throw something out to me. Something you know is already true. Woo! 21. Tell me something that's true so I can write down. Good. We're using our assumption there. AD, congruent to DC, definition of a bisector. Nice. I like it. What else is true? You relax over there, Mahmoud. All right. You got a question? All right, relax. 7. What else is true?
I'm sorry, I forgot that was me. Angle BDC and angle BDA are right angles.
They're okay. Yep. Avery knows a vocabulary term up here pretty well. Angle BDA and angle BDC are right angles. What word told you they're right angles, Avery?
Altitude.
There you go. Remember what an altitude does from this unit? Comes from a vertice perpendicular to the opposite side. You can do definition of altitude here. Or altitudes form right angles. That's good. That's a good one too. I'm not going to fight it though. Next up, what do you got for me? What else is true? Oh, Eva, look at this. You're barely called on anyway, so I feel zero sympathy. This is like the 4th time.
Angle BDA is equal to angle BDC.
Because they're what type of angles?
This will call it angle that-
Yeah. Good work. It looks like, correct me if I'm wrong, it looks like you guys are moving towards proving the triangle's congruent. Okay, I like that idea. Not yet, though. They're not congruent yet. No, no, no. 1. What else can I say?
BD is congruent to BD reflection.
All right, I'm surprised nobody said that right off the bat. Usually kids scoop that one right up. A little reflexive at you. All right, I would agree now that they are congruent. Step 7, they're congruent. Triangle ABD. Always remind yourself what your goal is. You want to prove it's isosceles because that's going to be your contradiction. ABD and CBD. Hey, what method are we looking at here? 18. What method are we looking at?
Side angle, side.
Yeah, we are. Can't get anything past you, class. Okay. Why are you proving the triangle's congruent? Great job. What, to get some more points? Get some more partial credit? Why do I want to prove the triangle's congruent? What's the effect? Go ahead, tell me what's the effect.
To prove that BC and BA are.
Now, by CPCTC, I can say one of two things. You pick. I could say AB is congruent to BC, or I can say A is congruent to angle C. You pick. Both will make it isosceles, and both are by CPCTC. You choose your adventure. AB congruent to BC. Oh, what do you got in your hands now? What do I have here? Or not? What do I have in ABC? $11. What's triangle ABC now?
That's isosceles.
Yeah, that's all I wanted. Thanks, Paul. Triangle ABC is isosceles. Now, if you did sides, you write the word sides. If you did angles, you do the word angles. For me, two congruent sides means I have an isosceles triangle. And now in the proof, what do you have? From the given to step 9, what is that right there? What did we just do?
Find a contradiction.
We contradicted a given, which means what about our assumption? You are false assumption. I just contradicted a given. My assumption is false, meaning the opposite. BD does not bisect AC. And then here it is, assumption led to contradiction. And again, don't forget, I know you're new at this, don't forget, tell me what steps your contradiction are located in. So always your givens as long as that's step 1. And then let's see, we contradicted it here in step 9. Can we also just talk? You guys just went double digits there, huh? How proud of you are there. You can go home and tell everybody, oh my God, we just did 10 steps today. We used to do 2 way back in the day. Now we're at 10. All right. Great. Good job. So proud of you. You've grown up so much in 3 months. I still don't like many of you, but which was true 3 months ago. Other questions? Maybe a handful. We'll see. Going? Okay, can you start the next one? Get out your Chromebooks. And when you're done, check the answer on the answer key because this is part of the homework right now. If you get stuck, call me over. I'm going to be hovering like nobody's business. All right, to make sure we're doing the correct work here. But you can check it. You don't need to raise your hand and say, check it for me. It's on the answer key on the homework. So please make sure you have an answer key out. I'll come around and hover around. Don't screw around. Let's get it done. You're doing this one on your own here. Can you do it?